So, welcome to this talk. I hope we're going to see. So, there won't be any slides on this one. So, this is a pure coding session. And before I start, I want to tell you a bit about this talk and the history of this talk, because I wanted to give this talk for like a long time ago. Probably when I worked on some extension to JUnit 5 back then, a couple of years ago, I had to touch reflection. I found it super cool. And then I submitted to some conferences. And I got always rejected. No one wanted this talk. So at some point I gave up. I never wrote this talk in the first place. And then last year there was a conference in Amman in Jordan. And then they asked me, hey, Danny, do you have a second talk? We have another slot available. I said, no, but I really wanted to write this talk a while ago. So they accepted it. I came to the conference. There's always something happening. So actually the talk gets scraped off the schedule. So it never happened. But this became the first of the version of the talk that we're going to see today. So I'm very happy that I can finally talk about this. I hope you enjoy this. Give me feedback afterwards. And the thing is, it's only live coding. And the last time I only did it twice. Because always something go wrong and I try to avoid it. So the first time I did it, I think I had a blackout on stage. I couldn't remember where the pipe symbol was, and on my German keyboard it wasn't printed. And someone of the audience had to help me. That was very embarrassing. The second time, remember the MacBooks where the keyboard was so bad? Actually, the E key fell off one of them during the live code. I think it's on YouTube, this one. So let's hope today it's going to be a bit better. So let's directly dive in. The laptop is a bit slow, so hopefully the coding will work. So to get started, I have to show you a warning, because this is the official warning from the Java docs. It says, reflection, warning, this is a relatively advanced feature and should only be used by developers who have a strong grasp of the fundamentals of the language. Why is it so dangerous? Because it can enable applications to perform operations which would otherwise be impossible. Sounds super cool, to be honest, so let's dive in. So I asked Wikipedia, what is reflection? And it says, so in computer science, reflective programming, or reflection, is the ability of a process to examine, introspect, and modify its own structure and behavior. Sounds super cool already. Let's ask what the Kotlin folks say about this. Reflection is a set of language and library features that allow you to introspect the structure of your program at runtime. Functions and properties are first-class citizens in Kotlin, and the ability to introspect them, for example, learning the name or the type of a property, is essential when using functional and reactive style. There's an essential point. When we think back of like reflection in Java, it was always like this black box, this magical thing where you had super ugly code. Actually, nowadays in Kotlin, you use reflection without even knowing about it. And this is part of this whole functional and reactive style. What I mean with this, let me show you. So let's actually dive into some code. So they have somewhere a method called isOdd, which just takes an int and returns a Boolean. So when we assign this to something, so let's assign it to, I'm not creative, isOdd. What's the type of this? I mean, we can say this is a lambda that takes an int and returns a Boolean. Right? Easy. But we can also say that this is a Kotlin type called function that returns a Boolean. This is not a Java function, that's a Kotlin function. We can also say that this is a K function. We can also say that this is a K callable. So I want to do a little deep dive in the beginning about all these types to show you where this is coming from, how they belong to each other. And then we get a bit deeper. We shall look into some examples, what you can actually do, how this is combined with the Java world, the interop world, and how it actually works behind the mirror. So let's go ahead. K-class is basically the type that probably all of us at some point had a look at. So I have this class called mdevcamp.eu, sorry. And when we do .class, I mean, you've all did this, right? This gives you a K-class. And probably you all know that Java, which gives you basically the Java version of the whole thing. So the Java reflection versus the Kotlin reflection type. Not spending much time on this, but the important part is that you can ask, for example, for its members, which by the way is a very interesting one, because members, I don't have a mouse cursor, that's interesting. Give me a second, because it's, don't see it. Oop. I just locked the screen. Well, I see it still here. This is super interesting. Let me unplug. So my computer froze. Let's hope it recovers in a second. It's completely disconnected, so I'm not sure what you're seeing there. The thing is, the members actually return to the functions and to the properties of this K class, which is very different in Java, where they actually separate the fields and the functions. Though also in, I think my computer died. What can possibly go wrong when you do live coding? Great. So this is what I'm seeing. Okay, let's give it a reboot. I'll try to cover the time. Okay, rebooting now. Cool, what I want to show you on the K class is very simple. It has properties that are very similar to the Java ones. Let me first reboot the computer, actually. Okay. It's now coming back. So very similar to the Java ones. Why would you use the Kotlin ones? Because K class has things that the Java version will not have. You can ask it, is this a sealed class? Oh, computer comes back. Give me a second. Okay, booting. You can ask if some is a class, as a data class, and these kind of things. So there's definitely a reason why you need reflection, specific Kotlin reflection ones in the first place. Okay, computer's back. Let's launch IntelliJ. No, I do not want to start Slack. Okay, project is back. Let's try. Ignore. Close. Something is happening. That looks better. Let's go presentation mode. Woo! Okay. We are back. Oh, it's actually all faster now, so maybe it was worth it. So, we've written in these methods. So let's be fast. So here you have all these, come on, compiler, indexing. Cool. Okay, so we have is sealed, is companion, all these things that are very important. Also for members, you have, for example, you can ask for static properties, static function, things like this. So very simple stuff. There's one thing that I want to mention. There's a thing called K-type and the class. And there might be sometimes a bit of the question, so where's the difference there? And I briefly want to show you a definition here. So a type can be an actually class with optional type arguments. The type of string is the class string. At that moment, they are the same thing. But also, a type parameter of some type parameter of some declarations can be type. So list T, where T is a generic type. This is where type comes from. Also, types can be nullable and non-nullable. So quickly, I want to give you something about type, because that's not something that you usually use. Nowadays, it's actually very easy to get a type. You can do something like type int, which gives you a K-type. This came, I think, in Kotlin 1.3. In the beginning, we didn't have this. Another way to get a type is, let's go to def.prac class. Let's assume we ask for the constructors. We was going to create one, right? I skip this part because of the computer slowing down. Let's get the first constructor. We need the arguments to start this thing, right? Parameters are called here. So it's K parameters. Let's grab the first parameter. And then actually here you can get the type. So this is one way where you cross around type for sure. And I will show you an example where I had to use this. You can also, if you have a class, let's take the Kotlin string. It has a create type. And there's indeed the difference. So I can give a list of annotations. I can say if this is nullable, sort of the class string or the type string, I can create a different type that's based on this. Usually you don't need it, but I'll show you later an example where I had to play a bit of this. More important is the thing that you use all the time, which is K functions. Very simple. Let's do the same thing I just did. Class constructors. So that is actually the first one. Well, CTR. That is a K function that creates the first part. Cool. I mentioned earlier that there's also a function, right? So this is actually also a function. So let's look at the difference. So function is an interface, which is just a marker interface. There's no method here. And this is basically represents internally just the value of a functional type. So a lambda is a function. And a numerous function is this kind of function. Or a function reference. So when we go back here and say it's a K function implements function. And by the way, K callable, which is another type we'll talk about. It becomes interesting when, let's do an example like I did earlier. So we have our function that is odd, right? No, is odd. So I said this was a lambda that takes an int and returns a boolean. Boolean. Yeah. Cool. It is also a function and a K function. So let's assign the same thing like we did earlier here. And let's make them vars. And the question is, I mean, as I say the same thing to them, can I assign them to each other, right? So can I do fun1 equals fun2? Doesn't work. I can't assign K function is not a lambda. But maybe work the other way around, because I can assign the same thing, right? Wait, this also doesn't work. The first moment a bit confusing. There's a slight trick. So these are the things when you start doing these talks, you find very interesting function. There's a function called reflect, which actually takes a lambda and tries to build this K function around it. It doesn't work all the time. It's very experimental. But this is something you have a look at. We'll look at actually the implementation a bit later, because it's very interesting. So keep this in mind. K callable, I jump a bit because we lost some time. So every K function is a K callable. Easy. It just basically has one nice method. So def.proc. Let's grab a method that has started here. So, well, fun. Yes, it has started. So this could be K callable. It's also a K function that returns a boolean. Every callable has a method called call, which then takes an instance, for example, the same way as you would do it in Java, or similar way. This is, by the way, one of the dangerous things. There's just call with a var arg. So there, why everybody says it's dangerous in the documentation, you lose all the type safety that we usually have, right? The compiler can't help you here. It will crash on one time, for example, when we try to run this. It will probably say, hey, you're missing to pass me a type. Cool. One type argument expected. Why is there a K callable if it's a function anyway? Because also there are properties. So let's grab perp1, which is also a K callable of boolean. And this could be, for example, there is, what do we have? We have a date here. Let's take the date one. Date is necessity field, so like this. So there's also a K callable. So getting the property via reflection, you do the same thing. You use a get. Though props also have nice things, they actually have a separate getter that you can get. Wait. Jumping one to forward, let me actually copy this. So a property is a callable too. So let's talk about properties. That's what I wanted to show you. So this thing is a K property. And K property, when you use it directly, you can, there's a separate getter that you can pass around, which is a very interesting one. But actually, you probably have seen a K property before, right? Because the first thing we actually reflection is used in the normal life, and property delegates. I gave a full talk about delegates a couple of years ago. Probably can find the slides online. But let me quickly show what the delegate is. So let's assume we want to create a new conference, right? So new, awesome conference. A conference, oh, come on. A conference needs speakers. So we need a list of speakers. List of speakers. Where do I get the speakers from? Wouldn't it be nice? What's going on here? Come on. I think we have the same thing again. Woohoo. Okay, nothing's happening here. Well, I unplug and give them a moment to come back. What's a property delegate? If I would say here, by, and for example, dev.camp.eu, the by is trying to access a property delegate. I think it's that again. Let's do the same thing. And you all know property delegates. Shutting it down. Trying to shut it off. At least one, and then using it probably every day. By the way, computer's already disconnected, so very nice cache over there. And this is by lazy. I think lazy is the delegate everybody is using. The platform has a few other built in that are hardly used, like as an observability one, for example, which is not related to the Java one. Let me quickly log in here. And in, not sure if you are using, but in the last company I've worked on, we use delegates a lot. Also in the SoundCloud code base, we have a few. To give you one example, we still have a lot of ArcJava. SoundCloud is one of the most heavy ArcJava code bases I've ever worked on. They were also one of the first ArcJava code bases. So we're just starting IntelliJ here. Loading. And one, for example, that we have is by disposable. So whenever you assign something, so this is a disposable, we say by disposable, whenever you assign a new disposable, it disposes the old one, which is pretty handy. So for these kind of things, where you need to clear something when we are assigning property delegates, for example, are super handy. And I will show you some other Android-related ones. So let's try to plug in again. Okay, cool. Let's go in presentation mode. Okay, we were at K-properties. Cool, so let's try the property quickly. So we wanted to have the class new conference that needs speakers. That is a list of speakers. Speaker. And we want to do this by dev.camp.eu. Cool. Of course, dev.camp.eu does not implement anything that is a property delegate. So how do we implement this? We can actually do it outside of the class. We can write an extension function. And here we see the K property. This is why I said you might have seen this. And for example, we can just return speakers. The cool thing with property delegates is that you get information about where this thing is used. So the second parameter here, property, we can actually ask this thing, are you final? Are you open? Are you suspend? Are you late in it? So you can ask, you get information about where your field is used before you assign the value, which can be very, very powerful. Oh my God, it died again. Okay, one more time, I think we all just gather on stage here and do it without the cable. Okay, this time I give it a second, maybe it recovers. So you have two variations. You can have an extension function, or you let your class implement this getter. There is a marker interface, a read-only property or read-and-write property that you can implement, but you don't have to, which is the nice thing for the delegates. This is why extension function actually work. I think even lazy is just an extension function. The other interesting fact, okay, not coming back. The other interesting fact, there was two parameters. Maybe you can't see them here because there's this dialog over there. You get information about the class that this is used. So you can use property delegates without the class, then you get just nothing. But if you use it in class, which usually you have this any parameters. What's the first one? And this is basically the class that your field is on. So you can have a different behavior depending on where your property delegate is used. So booting one last time here. So what's the usefulness? The example I wanted to show you is, let's see, we have the time. Probably we're skipping this one. So I wanted to declare a delegate in two classes. One is a normal class and one is a test class. And just say, hey, this is my int by property delegate. Both get the same initial value. and then run the code. And we can maybe do this later in the speaker's corner. But I try to reconnect again. And then have different behaviors. So the value is actually different because what we're trying to do here is let's take a class that we're in and figure out if this, for example, is this a JUnit class. It's not that simple. You can ask the class for its name, which yes, it would be test, but in the presentation mode. Quickly write this just to show it you. Because the property delegates, let's say this and write this example. So let's say we have a class, something, and we have some delegate, property, prop, by, let's say it's an int, by, and I have this property delegate already prepared for you here, and we give it the default value of 0. And then we're doing the exact same thing, Command D, whoop, and something test, no change here, doing exactly the same thing. And let's just actually run both. So something dot up dot prop and duplicate this line and something test. Let's run both. And this is where I try to do this. Have a different behavior. Oh wait, we still have the old okay, callable test. Should we move the, let's do it again. So the first one, I was not declared in a test, my value is 0. The second one, oh, I was declared in a test, my value is some random number. So property delegates here. How is it implemented? So this is a typical delegate. There's an operator actually for it to create one. This is a read-write property. I told you there's a read and a read-write version, so I can make this also var. And it's very simple. It just takes this reference and figure out if this is test. It could be as simple as this. Does it ends with test? It's not very reliable. So what we also tried is, also me and the colleagues thought about this. Let's figure out, let's take the stack trace and figure out if we actually called from something that is in org JUnit. So you can do some dirty things, and then it's like typical halting problem, right? Behave differently depending on where you're used. So go well with it, I would say. Just a small thing about coroutines. As you lose all the compile safety, when you use a k-callable and you call call, it will fail simply because you do not provide this continuation, because it's basically Java under the hood. There is a call suspend. I'm not showing this. So you can ask if a property or the method, hey, are you suspended? Is suspend? If yes, then do call suspend. So it's very simple, just keep this in mind. But we want to look at the interesting part. So how does this all work, right? And how does it work together with Java? So when we have the devcamp and we have the class, this was the K class, right? This was the Java version of it. By the way, you can go back to Kotlin and keep doing this forever. So it's very easy to go from one to the other. The Kotlin one is not much happening. But when you look at the code, you find these interesting utils. So there's a reflection class you can use. It's in the internal package, but it's public. It has this get or create Kotlin class. It doesn't do much. It just creates a reference around this Java class. It adds the additional properties. And this is why you have to, if you think about reflection, think about it just as some data structs in memory that just describes how this thing works. How is it named? What is its property? There is no magic here. And this is also why the lambda and the k function behave a bit differently, because it's just different description of the same thing under the hood. There's a thing that I didn't mention when it comes to types called type erasure. That's important when we talk about Java. Because we all know that when generics were introduced in Java, they were a bit weird because they only happen on compile time. So a list of string and a list of, I don't know, integers is the same thing at runtime. It's a list of objects. This is called type erasure. And we think of Kotlin and Java, there's another type erasure happening because types are changing. A Kotlin string becomes a Java lang string, right? And this is basically what you have to keep in mind when crossing these worlds. So let's do a print line of string class to Java. And maybe another one. Let's take an actually string. And there's also this called Java class. Let's just run them. So first one is a Kotlin string, the other two are Java lang strings. There is also, I think it happens on the type. So when we do the type of string, that's a very interesting one. The type has a JVM erasure, which is an interesting one. It tells us, returns a k-class instance. This will be translated on the JVM or erased to the JVM. Might be also interesting to look into this. Also, you can ask every k-class for its Java primitive type and object type, which might be interesting when you're dealing with primitives. And it's actually, the implementation is super simple, because they are only the built-in ones. This is the whole implementation. It's just a switch statement that translates one to the other. So also here, it's not much magic. But you need these kind of properties when you load something at runtime. For example, in the serialization example, to fit these. So, to be nice with time. So how does this work? To do this, let's go to our devcamp class and actually look at it, how this works on the bytecode level. So actually we don't need this, I just want to go in there. We want to show the bytecode of this one, and let's decompile it. So let's look for dev+park in here. Cool, there's class dev+park with all the properties, there was the speaker list, there's just decompiled bytecode. Nothing crazy, you've probably seen it. What you might have noticed if you ever looked at one is this. All the classes have these weird things here, which is basically an annotation with some weird values. And I've actually just made a copy of this. Let me go back to the file. So it looks like this. MVK, and then there's this, okay, you can see some strings here. This looks like the methods and properties of this thing. So what is this? Oh, there's annotation, so let's look it up. Let's open metadata.kt. And actually well documented, so you just have to look at the source code. So let's look at it. There was K1. K1 means this is a class. Cool. There was MV, which is the metadata version. This was, when we go back, 190. This is the Kotlin version I'm using here. So there's no magic here. XI, let's look at XI. I think it's the last one here. An extra bit represents the following flags. One, no, we had two, right? This class is compiled with Kotlin script. Why Kotlin script? Because I use this decompiler. This is just a Kotlin script that run to do this. And we run this as in our project, it will be a different value. But still very, very nice thing to look at. But interesting are these two big ones, right? So D1 and D2. So D1, it's a custom format. It may be different for different kinds, or even absent. And then the second one, here, additional data one, an array of strings which occur in metadata, written in plain text so that they're already present in the constant string pool, so for optimizations that are already there. Interesting? Let's do something with it. So how do we get this value? So I would say let's do the same thing that we just did the decompiler. Let's grab this annotation. Find annotation. And we want metadata, metadata, not class. And let's print this. Cool. Let's run this. Let's remove this. So what's this last one? It's empty. Why doesn't it work? Because I've tried to find the annotation on the Kotlin class. There's no need to have it on the Kotlin class. It doesn't sit there. It sits actually on the Java class. So we need, and here we go again. Great. Okay, I'll be with the computer because this is something I really want you to show. So as I showed you, the annotation sits on the Java class. So we have to take the Java one and use get annotations method. Booting. And then as the class is so nicely, the metadata class is documented and has nice methods, we can actually look at those and then try to look into what is this data one. Because that's a really, really nice one. While I'm booting here, I'll skip to the next session, which is some examples. One I wanted to show you is a property delegate. If you're an Android developer, let me quickly add my password. If you're an Android developer, you probably have maybe used some delegates like I have a view model and then I have something like a property which is of type string, and then maybe you use mutable state of, for example, or one of these mutable state flows. But then you also have the saved instance handle, right? You want to have this on recreation. And there's this really nice property, and I'll post it after this talk, that a friend of mine wrote, that is really helpful. That is basically by savable mutable state flow. It just passes the saved instance handle. And does all the magic under the hood for you. So this is like a really nice one, where you can hide a lot of things under this delegation. Cool. Computer is back. Actually jump before I connect to where we were to save some time. Nice. Back. Presentation mode. Cool. So we wanted to look at this annotation. I said we need a Java one. So we need get annotation, and we need also the Java one here. When we now run it, it should already print us something. Cool. This looks like the thing that we looked at. By the way, now it's still when it's the x. This is still a class, but the xi value is a different now, right? It was not the Kotlin script anymore. Cool. Let's do something with this. So this returns a metadata, right? So with this, I have access to data 1, data 2, and all this, but still, I don't know what these mean. And I found a really cute tool, a JVM protobuf, that's also part of Reflection, you have it, which has read class data from, and it takes 2 arrays. Oh, that's nice, I have 2. Let's call this, well, metadata. And give them metadata.1, and metadata.data2. Cool, what does this return? This returns a pair of one thing called a name resolver and protobuf. Oh, this binary thing is probably protobuf. So let's do something like name resolver and protobuf. Cool. And what can we do with this protobuf? So this protobuf class has everything basically that we later need in a K class. It has all the functions, all the properties. And the computer is dead. Cool. I'll leave it from here. So what you can do is you take this protobuf and, for example, you ask for the function list. And what I want to show you is do for each on them. And then you get like a function definition, but it's still very encrypted. It has like the name of the function is some random int. Why is some random int? Because the string sits in a different table. This is what the first parameter will give you, this name resolver. So combining the two of them, you can ask, hey, give me the name of this function. And basically you can see that all the properties that would be also in the K class, like is this suspend, is this, I don't know, final, they all sit in there. So this is the magic. So there's this one nice byte array. You can code it in a string that has all the information that you need. Interestingly, the computer booted itself. Don't have to do it myself. That's good. And why? How did I found this? Maybe I can show you at least this one. Examples. We were here, and we do presentation mode. And you know, there were some weird things that we just used, right? There was this JVM protobuf and all of these things. How did I find these? Remember very in the beginning, I gave you this is odd thing. I showed you that when you have a lambda, you can ask .reflect on it. So let's look at what reflect does. So it takes a lambda and wants to give you a K function. It uses this JVM protobuf read function data that I showed you with these two things. And then I just use them to create some metadata and some descriptor to create this actually K function. That's why I said all the things are actually in there. This is how I found this nice little tool to figure out what is in data 1. Cool, so this is this. Sorry that I had to cut it a bit, but I want to be nice with the time. So here's an example that I mentioned, the view model one. I just showed you this quickly. So you have a view model, and then you have these, hey, few strings, And instead of mutable state of, there's a savable mutable state that takes the save state handle. You can just hide these kind of things very easily in delegates. And I want to show you another example of things where I had to play with reflection. Because you might know I like tests. So I had this kind of tests. Let's assume we have something about a login method, and there's Facebook, Google, and Apple, and this is enum. Then I have a test. This is JUnit 5. That's parameterized test. I want to be this called for all the methods. So it calls it 3 times because it's the enum source. But what, and this was my problem, what if I have a sealed class? I have much more. These are social logins, but also there's a manual one with an email, and I want to test this. So what I was written is this sealed class data source, and it's open source. It basically does the same thing. It tries to go through all the sealed classes, because that can do with a K class and a K type, basically iterate over the sealed subclasses. And just to show you how this, show if this project is open, it's open. So this is just the implementation, I put it in here. For example, when I needed to create these arguments for the constructor, I'm taking the K-type and then just have a case for each of one. Ask for the K-type, what is your actually, what's your class? Sometimes it goes a bit tricky. You find some really interesting ones also sometimes. This project still runs an older Kotlin version, and what I found is that there was a bug, not a bug, but the Kotlin compiler prevented you from using enum.value of like generic at one time. It works in newer versions, but actually in the code still you will find this. There's actually Java class, like in the JetBrains code, to get around of this, which is very interesting. And this is what I had to use, for example, to create an enum. Cool. Let's go for the other project. That's it. Slides. So limitations. The whole Kotlin Reflect API, when I asked, I remember like a friend at Google, hey, I'm talking about reflection. She said, what are you supposed to talk about 45 minutes? It's like 3 classes, right? So it's not a very, I mean, yes, you have all these hierarchy ones, but there's not so much in there, because I think the designers of the Kotlin Reflection, they wanted the minimum that you need to have to handle Kotlin, but there's no fancy things around it. It's more about finding some properties. For example, there's no way with Kotlin Reflection, like with Java Reflection, to get a private type. Because if we can't see it in compile time, why should I see it runtime? So for example, if I had this case, and hopefully I don't have it anymore, I could do something on dev-fast-prac dot set, I don't know, there was a costs one, I think, to, I don't know, money dot the big decimal, I think it was a big decimal. So things like this is a third-party tool. Okay, you can make it a nice infix. Because Kotlin Reflection itself does not support something like this. You have to go to the Java one, because Java Reflection is much more powerful here. But it makes sense because they didn't want the language super unsafe. So there's some limitations. And let's talk about the elephant in the room. Yes, reflection is slower than not using reflection. But it's actually okay. There was a Google I/O a couple of years ago where actually the Android team said, yeah, it's okay. We're not saying anymore, don't use reflection. But use it if there's actually the need for it, right? And most of the time, there's not, except for certain things like the property delegates. This is basically what I wanted to show you. Sorry that we had to rush through some topics, but yeah, 5 times rebooting the presentation is a new record. So performance overhead we have as a sum up. Private members, for example, you can't easily access this. You lose the type safety, which is the whole point of Kotlin, but it's a very powerful tool. There are some links here, and I put it all online afterwards. But yeah, if you have some questions, shoot. And thank you. And sorry for the laptop.
Thank you, Danny. We do have a question. You can often read how expensive reflections are. How often do you really want to use it?
Yeah. So I remember this discussion was like in the earlier days of Android, we had this a lot, because there was also this warning of not using reflection on Android. It got better over time, but I remember, and it must be 2017 or 18, I was speaking with someone from Groupon, I think in St. Petersburg on a conference, and we actually did some measurements because they had dependency injection library called Toothpick, was like an alternative to Dagger back then, and they used some reflection. So it was partially reflection. And of course they knew that this copy came up, and they did some measurements. They can look at the old code. It wasn't that crazy as you might think, and it got better over time, also by the way the compiler switches between just-in-time and compiler head. It is still slower than not in using it. I mean, yes, but also running code is slower than not running code. So there is an overhead. Don't use it for everything, but it's like, I would say, use just your normal gut feelings. I mean, if I have a list of 100 things, I also don't over-optimize it, right? So the same with reflection. Don't build the whole app just because it's cool to use reflection. But unless you actually show a performance problem, I would, for nowadays, you can mostly ignore it.
Okay,
similar to the enum topic.
Shall we take one more question?
Yeah.
What was your personal favorite use of reflection to manage something that wouldn't be possible without?
Yeah, I'm very happy that I'm now working on a code base where the classes, like this, the structure is good and they're all unit testable. We have like, I don't know, thousands of unit tests. And I never had this case that I needed to set some private fields. But I remember working on a code base where this needed a lot, and you probably all did. So I needed reflection there, and this, unfortunately, Kotlin didn't support. So for Kotlin, I think my favorite use case was the thing that I just showed you, the sealed class, because I had like so many variations of something I needed to test, and it was actually fun seeing this like automatically generated.
Okay, that's it. Thank you very much, Danny Preussler.